Hi, so for today we're going to talk about exact DE involving trigonometric function, and this is still a part of a differential equation video wherein in our previous video we did an exact DE. You can check it out on my playlist in DE that we solve only those DE involving I think polynomial functions. But for today's video we're going to solve some problems involving exact DE involving trigonometric functions. And before we start, let's just have a little recap on how we are going to solve an exact DE. So we must recall that if this condition is met, the partial of m with respect to y is equal to the partial of n with respect to x. If that two is equal, we say that the DE is an exact DE. And of course, we need to apply partial differentiation on our terms here in M containing x and y and n containing x and y. And if we are done with testing for its exactness and found that this DE is an exact DE, so in order for us to solve for the solution of the DE, we need these two formulas wherein we have the partial of f with respect to x, partial of x is equal to m, okay, the term that has we denoted as m in terms of x and y, and of course partial of y over partial of f, with respect to y is equal to n in terms of x and y. So that is the formula on how we are going to solve an exact DE. So again, if you haven't watched my first video lecture about the exact DE, go back to that part, okay, wherein I explained there also these formulas in detail, much detail. So let's get started. For number one, we have this formula. Okay, we have this example. Okay, wherein we have e raised to 2y minus y cosine of xy dx plus 2x e raised to 2y minus x cosine xy plus 2y. And if we are going to recall, the term that goes with dx is that is xy, m as a function of xy, and the term that goes with the dy, that is the n with respect n in terms of x and y. So what I'm going to do first is to test for its exactness, wherein we're going to determine the partial of m with respect to y. So we're going to differentiate this with respect only to y. So in order for us to do that, what will happen here is that, okay, we differentiate this. That's very easy. That is 2e raised to 2y with respect to y. So this is partial derivative, if you're going to recall. Minus, of course, we know that this is y and this is in product with cosine xy. So we would apply the product rule for this. So we will be copying this first, okay? And then differentiate this cosine xy in terms of y. Notice that inside the cosine, we have a variable x that is not purely y. Okay, we have xy. So this x is considered as a constant. Okay, so what will happen? This is y, we copied it. Okay, and then what will happen? We differentiate cosine xy. So simply the derivative of cosine xy is simply negative sine, okay, xy. And of course, that is multiplied by the derivative inside with respect to y. If we differentiate this with respect to y, so treating x as constant, so we'll be having only x. Okay? So that's for the first part of the product rule. So plus, again, we copy this cosine xy, cosine of xy, and then we differentiate y. Technically, that's 1. With respect to y, that is 1. So, if we simplify this, we have 2e raised to 2y minus we have negative x times y is xy. We have negative sine xy here, so that would be negative xy sine of xy plus cosine of xy. Okay? Then we distribute the negative sign here because that is a minus here. So we distribute this. So this will be 2e raised to 2y plus xy sine of xy minus cosine of xy. So this is our partial of m with respect to y. Okay. So how about we get the partial of n, okay, partial n with respect to x, the partial derivative of n with respect to x. Again, if this is with respect to x, we need to consider the other variable as a constant. So, in order for us to differentiate this with respect only to x, so we would treat this e raised to 2y constant and we differentiate this. So, what will happen is if we differentiate this with respect to x, so what will happen? That would be 2 e raised to 2y. If we differentiate 2x, that would be only 2 with respect to x. And copy this, multiply this because this is a constant. These all are constant. 2e raised to 2y is constant. We differentiate x, that would simply be 1. So we have a partial of n with respect to x as this. Okay. That is minus because of this minus sign. And then with respect to x, partial with respect to x, notice that this is also x, cosine of xy. So again, we have a product rule here. So we copy the first, that's x, and we differentiate this cosine of xy. So what will happen? The derivative of cosine is negative sine xy. So we are differentiating with respect to x. So we consider here y as a constant. So if we differentiate this cosine xy, we will be having negative sine xy, and we need to differentiate also the inside term of the cosine, treating y as constant. So what will happen? If we differentiate this, treating y as constant, we differentiate it with respect to x, we will be having only y here. Okay, this y comes from the inside of the cosine function. Okay, and that is again plus copy, of course, the cosine of xy. Okay, so that's product rule, and then differentiate x. Simply that is 1. Okay, and of course plus differentiate 2y with respect to x. Since there are no x term here, 2y is considered as a constant because we are differentiated with respect to x. So the derivative of constant is 0. The 2y becomes now 0 because y is treated as constant because we are differentiating with respect to x. So what will happen? We have 2e raised to 2y minus we have x times y is xy. So negative xy. Okay, negative comes from here. Negative sine xy times x, negative x times y. So negative xy. Then we have sine of x to y here. Okay, and we have plus cosine of x to y here. Okay, and then distributing the negative sign, we have 2e raised to 2y plus x to y. Okay, sine of x to y minus cosine of xy. So see, this term is equal to this. So definitely, we have an exact D. Yes, we have not yet arrived with the answer. We only test for its exactness. So that is an exact D because the partial of m is equal, with respect to y is equal to the partial of n with respect to x. So how do we solve the D? So we will use these two formulas a while ago. We have the differential partial of f with respect to x is equal to m in terms of x and y. So how do we do this? This is now equal to the partial of x with respect to x plus, is equal to the m, which is the m term. This is the m term containing x and y. So that should be equal to e raised to 2y minus y cosine xy here. Okay? So as you can see here, if I'm going to cross multiply here, so what will happen? We have partial of f with respect to e raised to 2y minus y cosine of xy. I multiply this, cross multiply this on this side, we have the partial of x. So if we differentiate this, what will happen is that differentiating these two sides of our equation, integrating, I'm sorry. So we have f, and that f is equal to the solution. Okay, we will later on equate the two f we have. The partial of f with respect to x and the partial of f with respect to y. Okay, so we have this. So we can distribute the dx or the dx here and also the integral sign. So we have integral of e to y by properties of integral, we have now dx. That is still partial of x, but we can rewrite this as dx because we are now integrating. So we have minus integrate or integral of y cosine of x to y. We have dx here. Okay? So, we need to integrate. Okay, that's right. You heard it right. We need to integrate. So, what will happen here, since we are integrating with respect to x, any variable aside from x is considered as constant. So, hence, e raised to 2y, it has a variable 2y. So, that should be treated as a constant. And as a constant, by properties of integral, we can factor it outside the integral. So, that we have e raised to 2y integral of dx minus, again, this y is multiplied by cosine xy. So, we can treat y as a constant. We can bring it outside. Cosine xy cannot be brought outside of the integral because it has also an xy term. Okay? It has a y term also. So, it has also an x. So, we cannot factor this outside. So, we can factor out y, integral of cosine x y, we have the dx. So, integrate, we have e raised to 2y multiplied by x minus y. So, how do we integrate this? Okay? So, how do we integrate this? Remember that we are integrating with respect to x. So, we can treat y as a constant. Okay? So, if that is a constant, we need to have a correction factor of 1 over y in order for us to integrate this. Okay? So, we would integrate this, but we will be having a correction factor of 1 over y, okay, due to y is constant. Okay? It's just like the same as we have to integrate cosine, let's say 3x dx. So, what will happen? We compensate 1/3 outside of the integral sign and get directly the integral of this. So, that would be sine 3x. So, here, in our problem here, xy, y is considered as 3. Okay, that's considered as a constant because we are integrated with respect to x. So, we offset a value of the reciprocal of whatever value of this. In this case, that is y. So, we have 1 over y here. So, we can now freely integrate this, okay, as a sine xy because we have already compensated a 1 over y here. Okay? And if you can remember that we have q of y here because we are integrating with respect to x, so we can add a plus. This is a version of plus c, but more specifically because even though we add a q of y here, okay, if we differentiate it with respect to x, that becomes 0. So we have a q of y here. So what will happen? We have x e raised to 2y. Y would cancel. We have minus sine x of xy plus q of y. And this would now be our first f. Okay, this is very important. Q of y is very important. Please don't forget that. Okay? So, the next thing we're going to do is we get the partial of f with respect to y of the n in terms of x, y. So, in order for us to do that, we have partial of f with respect to y. Our n value is actually 2x e raised to 2y minus x cosine of x to y, okay, plus 2y. That is the term containing x and y in terms of dy. So we have here our n. Let me just go back. This is our n in terms of xy. So we already copied it. So what will happen here is that the same process, partial of f, we have 2x e raised to 2y minus x cosine x to y plus 2y. Okay? We have already the dy here. After that, we integrate. Okay, so as you can see, we integrate again. So we have f here. And we can distribute the integral and the dy. So we have 2x e raised to 2y dy minus the integral of x cosine of xy. Okay, plus the integral of 2y dy. So what will happen here? We are integrating with respect to y. So all other variables except for y is considered as constant. So 2x, 2 is constant, x is still considered as constant because again, we are integrating with respect to y. So we can factor that out outside of the integral, so we have again this, I forgot the dy here, we have a dy here. So we can factor out again x cosine of xy, dy here. We can factor out 2, okay, because that's a constant. So upon integrating this, we have 2x multiplied by, if we integrate this, that would be 1 half e raised to 2y minus x. Again, we integrate this with respect to y. So, if with respect to y, the x here is considered as a constant. So, what will happen? We will be having a compensating factor here of 1 over x because that's a constant, the reciprocal of that, and we can proceed with the integral of this directly. Okay? So, plus, we have 2 times y squared over 2 plus r of x. A function in terms of x. Okay? So, that's the exact DE. If you haven't watched my first video, please watch it. Okay, so I've explained it further there. Okay, so we have cancelled 2's here. We have cancelled x here. We have cancelled 2's here. So we have another value of f as x e raised to 2y. Okay, minus sine of x to y. Okay, that's minus. Plus y squared is equal plus r of x. Plus r of x. So what are we going to do here now is we have two values of f. Okay, what will we do is that we will equate this to f to find the value of r of x and also the value of q of y. So if we equate that, okay, let's equate that. Let's equate that x e raised to 2y minus sine x to y plus q of y, and that is equivalent to this f, x e raised to 2y minus sine of x to y plus y squared plus r of x. So in this time, we can determine the values of r of x and q of y to get the solution. So we have x e raised to 2y cancelled, negative sine x of y cancelled. So therefore, q of y is any, okay, is the value of y on the other side of the equation that purely contains y, and that is y squared. For r of x, we have the r of x here, the value or the expression that contains purely x on the other side of the equation. But since there is no purely x on the other side of the equation, then we can rewrite that r of x is 0. So therefore, our solution to our D is this one plus qy or this one. So I can choose this one with r of x, a value of 0. So the solution would be x e raised to 2y minus sine xy plus y squared. I chose this, but our r of x is 0, so it is plus 0, or in other words, we cannot rewrite. We can just drop it. So, and that is equal to c. Okay, we also always equate this into c. So that would be our answer for this problem. It's pretty hard, okay, because we are now dealing with harder examples of the. But I hope you are there. You can understand what I am trying to explain to you. So for this video, we have two examples. So let's get to the other example. Okay, so for number 2, we need to find the solution for this exactly y squared cosine of x minus 3x squared y minus 2x, we have dx plus 2y sine of x minus x cubed plus ln of y, we have dy is equals to 0. Okay, so how do we find this? Again, this would be our m in terms of xy. This would be our n in terms of xy. So we need to test for its exactness. So partial of f, or partial of m with respect to y. Okay, we differentiate this with respect to y, so all other terms are considered as constant, or all other variables except for y. So this is cosine x, that's constant. Okay, we can factor it out. Then we actually differentiate this as that is 2y. Okay, So we differentiate this with respect to y. Treating 3x squared as constant, we have negative 3x squared. Okay, because the derivative of y is simply 1. And we differentiate this with respect to y. So this does not have any y terms. So this is considered as constant. So we have minus 0 here. So the partial of m with respect to y would be 2y cosine of x minus 3x squared. Okay? So how about if we get the partial of n with respect to x? Again, that's the test for exactness. So we have with respect to x, so all y's are constant. So we have 2y. Differentiate sine of x, that is cosine of x, okay, minus, okay, this x cubed, derivative of that, that is 3x squared. And this is ln of y. We are differentiating with respect to x. This doesn't have any x. So this is considered as constant, and the derivative of constant is 0. So we have 2y cosine of x minus 3x squared. And as you can see, this one, okay, this one is equal to this one. So we can conclude that the partial of m with respect to y is equal to partial of n with respect to x, and therefore it is an exact DE. Exactly. So again, what are we going to do for our next step? So for our next step, we shall be using the formula, the partial of f with respect to x again is equal to the m in terms of xy. So what will happen is that we have partial of f with respect to x of our m, which is our my squared cosine of x minus 3x squared y minus 2x. We cross multiply it, so we have y squared cosine of x minus, we have 3x squared y minus 2x, and we have dx here. Integrating both sides of our equation, partial of f, and we have dx. So what will happen? We have f here. We can distribute the integral sign and the dx sign. So we have y squared cosine of x dx minus the integral of 3x squared y dx minus integral of 2x dx. So we are integrating with respect to x. So any variable other than x is again considered as constant. So we can factor out y squared, integral of cosine of x dx. We can factor out negative y. We have 3x squared, or even the 3, we can factor it out. So let's try. So factor it out, multiplied by y. So we have 3y. You have x squared dx here, minus 2 integral of x dx. So what will happen? F would now be equal to y squared multiplied by the integral of cosine, that is sine of x, okay, minus 3y times integral of x squared is x cubed over 3, of which these 3 would cancel, minus 2 times x squared, integral of x dx is x squared over 2, so we have the 2's cancelled, and plus, don't forget the q of y, okay, any function containing purely in terms of y, okay, so that's the counterpart of c, but more specifically in terms of y. So we have y squared sine of x here minus x cubed y, okay, minus x squared plus q of y. So this is our first value of f, and of course, we need also to get the other one, partial of f with respect to x, I mean with respect to y, because we've already done that. With respect to y, that is n in terms of x, y. So again, we have this, let me just take the shortcut. So we have the n multiplied by the dy. So what is our n? Our n is 2y sine of x, that is sine of x, okay, minus x cubed plus ln of y. We have dy here, okay. So we integrate. If we integrate this, okay, we can again factor out or distribute the integral sign. We have integral of 2y sine of x. We have dy minus x cubed dy plus integral of ln of y dy. So let's integrate. So we are integrating with respect to dy. So x is considered as constant as well as the 2. So we have 2 sine of x here, integral of y dy. Okay, and then we have x cubed is considered as constant because again we are integrating with respect to y. And we have integral of ln of y dy. Now notice that these two terms are easy to integrate. But how about the very last term? So this is an integration by parts ln of y dy. So let's notice that this is ln of y inside of the ln. So our u would be ln of y, okay, and our du would be 1 over y, okay, and our dv is actually 1 dy. Okay, we have a 1 here. So that is 1 dy. So it's simply dy. And we have a v that is equal to y if we integrate this both. So we can now integrate. So we have 2 sine of x, y dy, that's y squared over 2. These 2's will cancel. Minus dy is y. So we have x cubed of y plus, again, uv minus the integral of v du. That's the formula for integration by parts. So uv, our uv is y ln of y, okay, minus the integral of v. We have the v, which is y. Our du is 1 over y. Of course, this is with, I forgot, this is with respect to dy because we have dy here because this is differentiated with respect to dy. So we ought to have also dy here. So we have dy here. So what will happen? We have y squared sine of x minus x cubed y plus y ln of y, and this would cancel. The integral of dy would be y minus y. Okay? Plus, again, r of x. This is our second function. And again, second f. So again, we can equate. Okay? So from the first, we have y squared sine of x minus x cubed y. Okay? Then I think x cubed y minus x squared plus q of y, equating, we are now already equating the two function f. Okay? So we have y squared sine of x minus x cubed y plus y ln of y minus y plus r of x. So what will happen is, again, to determine the values of q of y and r of x. So y squared sine x would cancel. X cubed y would cancel. Okay, so what will happen here? We have what? A value of q of y. Still, q of y, we have y ln of y minus y. Okay, the q of y is found, again, on the other side of the equation, wherein that term contains purely in terms of y. And it so happened that we have this y ln y minus y. Or this is also equal to y, okay, ln of y minus 1. Okay? That is still equal. We only factor out y. And how about r of x? The value of r of x, well, of course, is on the other side of the equation containing purely in terms of x. And that is negative x squared. So we can use, it's either this or this, but we need to plug in the value of r of x or q of y. If we use this, we plug in the value of q of y. If we use this, we plug in the value of r of x. So in this case, I'll be using this side of the equation. So our answer to this d is therefore y squared sine of x minus x cubed y minus x squared plus q of y, which is this, the simplified y ln of y minus 1. And don't forget that that is equal to c. Okay, the constant. Therefore, our solution for this differential equation, exact differential equation involving trigonometric function, is this. And that's it, guys. I hope you learned something for today's video. It's a very long process, but it's worth practicing and it's worth solving, because if you arrive at the correct answer, the feeling is really great. Okay, and I hope you guys enjoy this video. Don't forget, if you are new to my channel, please don't forget to subscribe. And if you would like to see other tutorial videos, please visit my playlist or my other videos. It might help you. So thank you so much for listening, and God bless you.